Welcome to the Defense and Aerospace Report. I'm Vagan Radian here at the Excel Center in London, where we're covering the DSCI trade show. Our coverage here is in partnership with DSCI and Clarion Events, and we've got with us Dan Middleton, who is the Executive Vice President at Liquid Robotics, which is a Boeing company. Full disclosure, Boeing is one of our sponsors. So Dan, tell us a little bit, Waveglider, very popular line. You guys have been steadily fielding a series of improvements to it. Talk to us about the latest model which you guys announced last week.
Yeah, so last week we announced our newest generation of Waveglider, and after 10 years of work, this is our third generation product. We put a lot of work into it the last 2 years, understanding the more difficult missions. So what we found is it's easy to do a mission in the Gulf of Mexico or in nice placid waters for a lot of these unmanned surface vehicle technologies. But our customer base isn't that. They really want to see us go extremes on the latitudes, where it's really difficult, less sunlight, extremely rough seas, high sea states that we have to live through for 6, 9, 12 months at a time without being touched or seen. So that's a whole different paradigm in the industry. And so at this stage in the game, Liquid Robotics is now declaring that we have a technology that can operate in those conditions. So we put in about 30% more power from a battery perspective. The solar panels are much larger and more capable now. But the largest invention or improvement has been the sub and the umbilical underneath the Waveglider being able to handle 10-meter high seas on a continuous basis, extremely rough. At some stage, we'll show you the videos of the Waveglider operating in these kinds of conditions. It make for great, National Geographic news, if you will. But the Waveglider is our flagship, as you know, and we're part of the Boeing company now because we're able to operate for both science and defense missions and environmental missions in any conditions. You don't have to wonder, where can I put a Waveglider now? You're able to put it in the ocean and have confidence that it can run through storms or long sea conditions.
What used to happen if a 10-meter wave hit one of your earlier Wavegliders?
So the Wavegliders in general are very capable in terms of rolling over with waves. Depending on where the wave's coming from, you may find that a Waveglider gets flipped, but it rights itself. Right, so the testing that we were doing to improve was how long can a Waveglider sustain that kind of rough sea state without any damage to it or degradation to the mission. So that's what we've upgraded now, is the ability to operate without degrading the mission through those sea states. But you'll have to see it to understand it.
Tell us a little bit about, is it more of a hot rod? I mean, you guys have upped the speed a little bit. You guys are now, I think, at a blistering...
We're running between 2 and 3 knots now.
Right. Wow.
Right. So that may not sound blistering, but it actually is when you put it in the context. It's 24/7, 365, going 20, 30 miles a day in different directions. That's a considerable distance you can cover.
Well, it used to be like 1.5 knots or something like that. So you guys are really booking now.
Well, we are, right? So we're pretty proud of our engineering talent. We've really trying to get the speed. Again, isn't a priority for us because it's about persistence and staying in the ocean and staying on course, and being able to fight against current or against storms to stay on station or to run a pattern. And we were able to do that before. So what we're seeing now is we can just do that in more extreme conditions that we might face in the ocean.
And so you guys have incorporated this change already on the production line?
Correct, yes.
And how big of a change is it to the body of the vehicle, its footprint? You do have a little more power capability, but generally, you've already gone through a couple of footprint changes.
Yeah, so the physical length is the same. You'll find that the Waveglider floats are slightly larger in terms of width, because we want to be able to hold more capacity, more flotation within the surface expression. The real invention's on the bottom. So in the sub, we found ways to dramatically strengthen that member, and from a physics perspective, how does the sub work in high sea states? So how does it float, how does it drop, how does it move forward? So that's where the engineering's taken place, is in the way we've constructed the wings.
And in terms of pulling a payload, are you able to pull a bigger payload, for example, now than you were before? In part, do you have a little bit more horsepower?
I think we do have more horsepower, but we already could tow between 1,000 and 2,000 pound loads underneath the water, so there's not a lot of those out there right now. So I think we were never in danger on the tow capacity, but again, we can now do that, but in rougher seas.
Right. Dan, thanks so very much. Fascinating product as always, and always great to follow up with you guys. Thank you.
Pleasure. Thank you, Vago. Appreciate it.